So this last type of mass movement happens in the submarine setting. So this is occurring underwater. All the other ones we looked at occur on the land, up on the air. But here underwater we have three different types. And some of these we've actually seen before. The submarine slumps are basically the same thing as subaerial slumps, but it just occurs underwater. So here you can see the same thing. We've got our scarp head, toe of the slump, and the materials falling down in these big coherent blocks. So you can easily get same thing. If we have sediment that doesn't quite stick together, those nice coherent blocks, however, we can get a debris flow or a turbidity current. So a debris flow, that sediment isn't moving as big coherent blocks. It's moving more like a slurry, but it's finer, or it's a slightly heavier grained material. So you can see it's flowing downwards. So debris means our rock and our fine sediment. But if we have just our finest sediment, what's going to happen is we're going to get a turbidity current. And turbidity current is just water that's got all of this dissolved material in it, and it's moving downwards in this big rolling type fashion as it moves down, as you can see in this picture. So why does mass movement occur? Well, usually our material is weakened somehow. Usually weakened by erosion and weathering, or it just could be, right, we have a very unstable surface and gravity is going to continue to act upon it. So basically our material is going to start to get broken apart, and gravity is going to pull on it, and it's going to fall down. It's a pretty simple concept. So slopes aren't even, I wouldn't even say they're stable. They're pretty much always unstable. It just depends at the rate they are unstable. Some appear to be stable for longer than others. But basically the stability of the slope is dependent on two factors: the downslope force, which is just gravity, and the resisting force. So if you've got a big boulder sitting on the side, it might have a higher resisting force because it's got more weight behind it, right? It's much heavier than, say, maybe a small pebble or something like that, right? That its resisting force isn't as large, so it might get pulled down a lot easier. So obviously downslope motion occurs when gravity is working much harder than the resisting force. We can also talk about the angle of repose, which is the angle that material can get to. So here you can see in this picture, right, these are actually volcanoes, but right, they've got angles on the sides of them. That angle is completely dependent upon the material. So as you can see in this bottom picture down here, I've got sand on one side and gravel on the other. Well, sand is a very fine particle, so I can't build it up in a tower too tall here, or in a pyramid shape, because it's such fine-grained material. It doesn't have a high resisting force. So you can see the maximum angle attained is only about 30 degrees. However, if I've got pebbles, right, which are much larger pieces, so it has a higher resisting force because it's got more weight behind it, you can see I can attain an angle of 45 degrees. So it really just all depends on the size of the material that we're just talking about. But as we've talked, right, any weak failure right below the surface can initiate motion. And there's 4 types of surface failure. We can see where we've got sand or clay that's just saturated with water, and therefore anything on top of it's going to move. We can have areas where we've got broken pieces that are parallel to the surface. So here, you can see we've got this rock that's got this bedding plane in it, and it's kind of parallel to the folding on the surface. So this is easily how we can create a slump. This big material is going to just slide down that natural bedding plane. We can also have very weak bedding in between here. So maybe these contacts are very, very weak, or it's got a weak rock there sitting in between the two. So you can easily get movement occur right along that weak bedding plane. Or this last topic, which is something we're going to see more of when we get into Chapter 8, and this is called foliation. This is a metamorphic process, and basically what happens is as my rocks are exposed to pressure and temperature, they can form these layers, essentially. The crystals are going to realign to become parallel with the direction of pressure, and that can create these layers, and those layers are what we call foliation. And sometimes those foliation planes can be essentially, for lack of a better word, slippery, and that can cause materials, you can see here, to slide right on that foliation pattern. Sometimes humans cause destabilizing events. As you can see here, we've got some road work going on, and here you can see we're easily creating a very unstable slope there. Or sometimes all it takes is a big truck driving down the road, causing enough seismic that's going to make the slope unstable. Sometimes really you can get things like lightning and thunder that can do it, right, and cause slopes to become unstable. So it just really, again, all depends on the material and how quickly it can become unstable. Changes in the slope itself can also cause can cause a destabilization event. So the first one is what's called loading. So loading is where we're adding weight on the slope, and 9 times out of 10, the weight that we're going to add is going to be water. So if you can see here, we've got an area that's undergone maybe quite a bit of rain, and so that ground is very heavy, right? That groundwater is just sitting in there making the ground heavy. It can push down on the ground here, as you can see, and cause these big slumps to happen. So as we add more weight to the ground, it can become unstable. Or by steepening an angle. So sometimes that naturally happens with, like, say, river incisions, but sometimes, most of the times, this happens due to human intervention, where maybe we see an area that we want to build a road, so we have to make a very steep angle, make a steep cliff. Obviously, when you make cliffs and steep angles, those are not going to be very stable for long, and the material is going to fall downwards. Removing a support beam can also cause mass movement. So here you can see this is actually what Niagara Falls looks like. So we have water that's actually flowing over the edge. And what happens is it flows over the edge, it hits down here, and it starts eroding out this base. So you can see as all the waves are hitting these rocks, it's eroding out this base a lot faster than the top is getting eroded. So what happens here is as this works backwards, this material is going to fall downwards, right, creating a rock fall. We can also change the slope strength. Weathering definitely creates weaker soil that sits on top. Here we can see a slump in action. So as the ground is exposed to wind, water, rain, ice, it's going to just continue to weaken that slope, and therefore weaken the resisting force. However, sometimes we can see that vegetation actually stabilizes the slopes. So here we have a slump, but you see lots of grass has grown on it. So all of that material hasn't completely fallen downwards because those roots are acting like an anchor system, just holding all of that material in place. So what we tend to see is after things like forest fires, where all of that vegetation is gone, we have definitely a lot more landslides because we don't have any of that anchoring material there any longer holding that stuff in place. So as we talked about, if we add weight to our slope, that can cause it to become unstable. And water is by far the easiest thing to add to a slope to make it become unstable. It adds a lot of weight. Water is very, very heavy. And not only is water heavy, but it goes in and it now acts as a lubricant in between the grains, actually allowing stuff to, a material to move a lot faster. But in the same token, if we have an area that's super saturated, but maybe it's stable, and we decide to remove the water to maybe, as we think, it would be more stable, that can actually cause a destabilizing event. Several factors play into mass movement. So areas that have a high relief, meaning they have steeper slopes, are going to have much more mass movement. So places like the Grand Canyon, right, there's lots and lots of cliffs. You're going to see more mass movement there than, say, Kansas. Climate also plays an effect. Wherever you have more rain, thus again maybe adding more weight and lubricant to the rocks, you're going to have many more mass movement events. And then, of course, the ever-present tectonic forces can create mass movement. As we get uplift, say in mountains, right? The higher we lift something up, the more gravity is going to pull down on it. So that can create mass movement. Fragment crust, as we maybe get faults like the San Andreas that become very active, and that material starts moving, it's going to pulverize that material, make it much easier to fall apart. Or if we are in an area of earthquakes, earthquakes are shaking the ground, so if your ground is unstable, it can easily, that shaking, right, can cause mass movement to occur.